Okay, let's unpack this. We're going to dive into a pretty crucial corner of the software world,
Yeah.
modern Haskell tooling. Specifically, we're dissecting the experience of using Stack, the project management behemoths, to bootstrap a new application
Right, from a cold start.
from a cold start.
Yeah.
And for anyone who works with compiled languages, the friction you hit in those first 5 minutes,
Mm.
that can often dictate how you feel about the whole ecosystem.
Absolutely.
So our core question today is simple, but I think it's really powerful. Does Stack's famous promise of stability, long-term dependency stability, does that outweigh the very real friction that developers seem to hit right at the start?
And that tension is exactly what our source material gets into. We have this detailed step-by-step walkthrough from a developer. They were setting up a simple sample app they called Fish, and they logged everything.
Every little snag.
Every snag, every warning, and eventually some moments of real appreciation. And what's great is they draw these direct comparisons to other tools like the older standard Cabal init.
Right. So our mission here is to guide you through that journey. We're going to unpack the rigidity that Stack's template approach kind of imposes. We'll zoom in on its most critical innovation, that's the snapshot system, and then we'll pull apart the exact manual tweaks that this developer had to do right away just to get their new project feeling functional.
So we're giving you the shortcut, really, a way to understand the trade-offs before you even type that first command.
Okay, so let's start right at the beginning, at that kind of cold shower moment. Running Stack new fish.
Yeah.
The developer was immediately struck by the difference between Stack and Cabal in it.
Oh, completely. Cabal gives you a questionnaire.
Exactly. It's a guided process. It asks you questions, customizes the project. Stack, on the other hand, it's a template dump.
It just drops the files.
It's fundamentally rigid. It gives you this fully formed, very opinionated project structure and basically says, okay, conform to this.
It's two totally opposing philosophies, isn't it? It's like Cabal offers you that hand-holding up front, but Stack says, look, here is a structure that is guaranteed to work. Now you go and fix the details.
And before they could even start fixing those details, they hit a pretty serious alert.
Yes, the environment warning.
The ever-present shadow of environment management.
Exactly. They were running Nix on their system, and Stack immediately threw a warning saying, hey, my integration with Nix is disabled.
Which is fascinating.
It is. It's Stack signaling from the very first second, I see you have this high-level environment control tool, but I'm going to ignore it unless you explicitly tell me to use it.
That feels like the universe just shouting at you, maybe now is the time to finally learn Nix.
The author basically said as much. They mentioned they'd been putting off learning Nix for years, but this constant pressure from the tooling might just force their hand.
So what was the short-term fix?
Oh, for now, Stack gives you the escape hatch. You just set notify if Nix on passpot, false in a config file. But the bigger takeaway for you, the learner, is that Stack knows it exists in an ecosystem where these reproducible build environments are, well, they're everything.
And that path almost always leads to something like Nix.
Inevitably.
Okay, so they silenced the Nix alert. The next major trip up was what we're calling the metadata hole.
Right.
Cabal, the competitor, it usually auto-populates your name, your email.
Yeah.
It pulls it from your git config.
A simple courtesy.
A simple courtesy that Stack did not extend.
And that silence forces you to stop and intervene manually. The template Stack uses requires, I think, 5 specific parameters that were just missing.
What were they?
Let's see. It was author email, author name, category, copyright, and GitHub username. All blank.
That's a lot to fill in. And if this is supposed to be the automation solution, what were the fixes it suggested?
Well, the fixes weren't exactly streamlined. You had 3 paths. One, you could dig into a global config.yaml file, which who wants to do that when you're just starting something new?
Yeah.
2, you could pass every single missing parameter as a command line flag, which is just clunky.
So it almost feels like it's punishing you for not having your own custom template ready to go.
Precisely. And this is where the rigidity really bites. The developer found that a critical field, like the project license,
Yeah.
you can't even configure that in the global config.yaml file. It's not an option. If you want, say, an MIT license instead of the default, you must create a custom template, or, more likely, just go in and manually edit the file after it's been created.
So it solves dependency headaches down the road, but it demands all this upfront manual diligence.
Okay, but now let's pivot from that initial friction to the feature that really makes Stack so powerful, the thing that wins developers over.
The payoff.
The payoff. Once the project is generated, Stack does its main job. It selects a resolver, or what we call a snapshot.
Okay, that word snapshot. That sounds a little like marketing jargon. I mean, how is this really different from a lock file in Node or a gem file in Ruby? Don't they lock dependencies too?
They do, but they lock your project's dependencies. A stack snapshot is, well, it's much bigger than that. Think of it like a perfectly curated, pre-tested, frozen version of the entire universe.
Okay.
It's a specific GHC compiler version, plus a curated set of hundreds of Haskell packages, along with all the required flags and options. The guarantee isn't just that your dependencies work, but that everything in that snapshot is known and proven to build together. No conflicts.
That sounds like a massive stability blanket you just throw over the whole build process.
It is. For this fish app, Stack looked at 14 different snapshots and it picked one, las2424.yaml. That string defines the exact stable state of the world for that project.
And this is where the source author's frustration just seems to melt away.
Oh, completely.
It's a huge emotional swing. They said they frankly loved this approach, and then they immediately compared it to other ecosystems.
They did. They called out Elixir specifically. They talked about how hard it can be to make sure your dependencies are compatible with a specific version of Erlang OTP. You're manually hopping between GitHub repos, reading issues.
Just trying to figure out if library A works with platform B.
Exactly. And that points to a huge failure in a lot of tooling, right? When you have to rely on forum posts or just digging through repos to confirm compatibility, you're trading automation for tedious research.
And Stack's snapshot system basically says, we did the research for you. Here's the guarantee, packaged right into the tool.
It solves an entire class of problems dependency hell before you even write a line of code. It's the ultimate trade-off. You suffer through the setup, but you get this guaranteed stability in return.
So Stack uses these snapshots. But what's going on with the files underneath? I know HPAC and Cabal are involved, and there's one file you're apparently forbidden from ever touching.
Right, and that's a huge behavioral shift for a developer. So Stack uses HPAC's package.yaml. That's your main human editable configuration file. HPAC then reads that YAML, and it generates the traditional Haskell.cabal file for you.
So fish.cabal in this case.
Exactly. And the reason you never edit that .cabal file directly is that the very next time you build, HPAC will just blow away your changes and regenerate it from the package.yaml.
It trains you to treat it like machine output. The source of truth is now the YAML file.
The YAML is the source of truth.
So once Stack has done its job, it's created the app, src, test directories, the config files, the developer was still left with a bunch of immediate cleanup.
Yeah, the defaults they weren't quite right. We've established Stack values stability over initial convenience, and that definitely extends to the generated files.
So tweak number one, the readme.md file was surprisingly sparse.
Sparse is putting it lightly. It contained only the project title, #fish.
That's it.
That was it. The critique was pretty sharp here. It lacks the most basic instructions. How do you build it? How do you test it? How do you install it with Stack?
And that's a huge problem for onboarding anyone. I mean, even your future self 6 months from now. You shouldn't have to Google the Stack build command for your own project.
It needs that context.
Okay, let's move to tweak number 2. This one was inside the package.yaml file, the description field.
Ah, yes. It defaulted to a URL pointing to the readme.md on GitHub.
Which is a common practice.
It's very common in the Haskell community, yeah. The idea is to avoid duplicating documentation. You keep everything in the readme. You don't have to deal with haddock markup inside your Cabal file. It's simpler for the maintainer.
I can see the logic, but the source author found it really limiting. It sacrifices that immediate context, just a quick sentence telling you what the project does, for this future convenience. It forces you to click a link.
It's that classic trade-off again, maintainer efficiency versus user convenience.
Okay, and the third tweak was pretty practical, the executable name.
Right, the default name was fishx.
Which is not what you want people to type in their terminal.
Not at all. You want them to type fish. So you have to go in and manually edit the executable section of the config. It's a small thing, but it's another one of those little friction points.
And finally, let's just touch on the last couple of files. There was stack.yaml.
Right. That one's pretty simple once you strip out all the comments. Its main job is to define that resolver, the snapshot URL.
And what about setup.hs? It generated that file, but the developer said you can just delete it.
You can, and you probably should. It's basically a remnant, a legacy file for backward compatibility with older versions of Cabal.
So it's just clutter.
It's project clutter. Modern Cabal and Stack don't need it. It's one last piece of cleanup you have to do right after you start.
So what does this all boil down to for you, the learner? We've walked through this journey of bootstrapping an application with Stack. We've landed on this clear duality.
Hmm.
On one hand, you have this incredibly powerful, stable dependency management through the snapshot system. It's a huge quality of life feature. It just solves so many problems before they can even start.
But that stability isn't free. You pay for it upfront. Stack imposes this rigid, default-heavy configuration process that requires you to immediately start fixing things manually. Metadata, executable names, ridmams.
It's a sharp contrast to the more interactive, hand-holding approach of a tool like Cabal.
It is.
The ultimate synthesis seems to be that Stack trades that initial friction for guaranteed long-term stability. And that raises a really essential question for you when you're evaluating any new tool.
Yeah, where do you place the most value? Is it in a friction-free setup that lets you start coding in like 30 seconds?
Or is it in the guarantee that your project is going to keep building reliably 3 years from now, no matter how much the ecosystem churns?
And let's end on a provocative thought. Building on what we saw in the very first step of this process, that immediate Nix warning, it suggests a larger, maybe unavoidable trend.
Go on.
For a serious Haskell developer who is chasing truly reproducible, truly isolated build environments, full integration with a tool like Nix might not just be helpful, it might become essential. So the question becomes, how much extra overhead, how much friction are you willing to accept in those first few setup steps? If it promises total control and reproducibility down the line, that's something for you to mull over as you continue your own learning journey.